Welcome to Types of Data, Measurement Scales, and Basic Sampling in Practice. In this session, you will learn to classify data types, pick suitable scales, and choose simple sampling methods. We will keep it practical with everyday examples. You will also learn simple ways to reduce bias and improve clarity. These skills prevent wasted effort and misleading conclusions. They also help teams align and act on evidence. Take notes on definitions, examples, and checklists you can reuse. Start with the core split, discrete versus continuous data. Discrete data arise from counting. They jump in whole steps. Continuous data arise from measuring. They can vary smoothly within a range. Discrete variables often have a smallest unit, like one person. Continuous variables can be refined with better instruments. You can bin continuous values, but they remain continuous by nature. Think about how you obtain values. Counting yields discrete values. Measuring yields continuous values. Here are everyday discrete data examples you will recognize. Number of support tickets received today. Defects found per unit inspected. Customers waiting in a queue at noon. Goals scored in a match. Cars passing a checkpoint in 5 minutes. Survey responses coded as categories. Each is a count with whole steps. Now consider everyday continuous data from measurement. Temperature at noon in degrees. Time to load a web page in seconds. Height of a plant in centimeters. Weight of a package in kilograms. Revenue per transaction in dollars and cents. Distance a runner covers in kilometers. These values can vary smoothly within a realistic range. Measurement scales describe what operations make sense. 4 classic scales are nominal, ordinal, interval, and ratio. Nominal labels categories without order. Ordinal ranks categories with order but uneven gaps. Interval has ordered values with equal gaps and no true zero. Ratio has equal gaps and a meaningful zero, enabling ratios. You choose analysis by the scale. Choose plots and statistics that respect scale properties. Misuse causes wrong summaries and claims. Match each scale to common examples and allowed operations. Nominal, shirt color, product type, city of residence. Operate by counting and mode. Ordinal, star ratings, pain levels, education levels. Operate by medians and ranks. Interval, temperature in Celsius, calendar year. Operate by differences and means. Ratio, age, weight, income, time duration. Operate by all arithmetic, including ratios. Do not compute means of nominal labels. It is meaningless. Scale choice guides, summaries, and tests. For nominal data, use counts and proportions. For ordinal data, use medians, percentiles, and rank tests. For interval and ratio data, use means and standard deviations when distributions are stable. For skewed data, prefer medians and robust spreads. Plot categories with bar charts. Plot continuous variables with histograms or density plots. Respecting scales avoids false precision and improves decisions. Now choose a sampling approach that balances effort and fairness. You want a slice that reflects the whole. Prefer some randomization, even if minimal. Convenient sample with checks, like first 50 cases today. Acknowledges bias. Systematic sample, take every 10th item on a list. Time-based sample, capture all cases during 2 random hours. Location-based sample, visit 2 randomly selected stores. Random selection using a spreadsheet, draw 30 order identifiers. Intercept sample, ask every 5th passerby during lunch. Keep sample size realistic and track how you picked it. Bias creeps in silently and bends results. Plan defenses before collecting data. Selection bias when some groups have no chance to be picked. Non-response bias when selected people decline or cannot respond. Measurement bias from poor instruments or unclear questions. Observer effect when behavior changes under observation. Survivorship bias when failures vanish from records. Recall bias when people forget or misreport. Reduce bias with randomization, follow-up, calibration, and clear protocols. Operational clarity prevents arguments and rework. Write rules before sampling or measuring. Define each variable in plain words with examples. Specify units, resolution, and rounding rules. Set inclusion and exclusion criteria with time windows. List data sources and who records each field. Decide how to handle missing, duplicate, and outlier values. Pilot your process on 5 cases and revise. Documenting decisions preserves consistency across people and time. To summarize, classify variables as discrete or continuous by how values arise. Choose the right scale, nominal, ordinal, interval, or ratio. Select a simple sampling method that includes some randomness. Name and reduce likely sources of bias. Finally, write clear operational definitions and test them. These practices produce data you can trust. They also make analysis faster and easier to explain. Start small, stay systematic, and keep notes.